In this video, we are going to learn about arithmetic progressions. Here you can see some sequences. Here you can see 100, 150, 200, 250, 1, 4, 9, 25, 10, 20, 40, 80, 160, 1 upon 5, 1 upon 10, 1 upon 15, 1 upon 20, 1 upon 25. You can definitely see that there is something common in each of the numbers which comes forward, ahead. In this one, if you look very carefully, you can see 100, then 150, then 200. Every time it is increasing by 50, or every time 50 is added to get the next term. In the second one, if you see, these are actually the square numbers, the natural square numbers. In this third one, you can see 10, 20, 40, 80. Here you can see every time the number is doubling itself. That is, it is multiplied by 2. And in the last one, last sequence, you can see that the denominators are always increasing by, numerator remains same and denominators are increasing by 5 every time. So these are the different types of sequencing. Now, out of all these, the first one, if you see, every time to get the next sequence, we have added plus 50. Plus 50 is done. Addition of 50 to get every next term. Here, these are the square numbers. Square numbers. In the second one, if you see, 10 multiplied by 2, 20, 20 multiplied by 2, 40, 40 multiplied by 2, 80. So in this case, every time 2 is multiplied. And here if you notice that the denominator, in the denominator every time plus 5 is done and numerator remains the same. Now any sequence in which to get the next terms a particular number is added, like in this case plus 50, then such a sequence is called arithmetic progression. This is an arithmetic progression. Okay. Then this is no particular progression. In the third one, 10, 20, where every time a particular number is multiplied, a same number is multiplied to get every other number, this kind of sequence is called a geometric progression or geometric sequence. Then here, when the numerator remains same and the denominator is an arithmetic progression, such a progression or sequence is called harmonic. Harmonic progression. So we can see there are three types of progressions. Arithmetic progression, in which a particular number is added. Geometric progression, in which a particular number is multiplied. And harmonic progression, in which numerator is same and that the denominator is in arithmetic progression. Now we are going to learn arithmetic progression in detail. Now here there is a sequence given: 5, 7, 9, 11, 13, 15 and so on. So let us first find out whether it is in arithmetic progression or not. And just observe, 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 11, 11 plus 2 13, 13 plus 2 15. That means every time we are adding a 2 in order to get the next number. So this is an arithmetic progression. Now 5 is the first term here. So the first term of any arithmetic progression is denoted by A, or you can just say it as A1. And in this particular example, A or A1 is 5. Then the number which you are adding in order to get the next numbers is called the common difference, and it is denoted by a D. And in this case, D is 2. And how do you get this D actually? In order to calculate D, what do? You do is, if this is A, this is A2, this is A3, A4. each of the terms are named in order in which they come. So A1, A2, A3, I will just write here so that you understand. A1, A2, A3, A4, A5, A6, and suppose this continues, the last term you can call, or it continues, it can be called as AN. So in this case, if you have to find D, it is going to be either A2 minus A1 or A3 minus A2 or A4 minus A3. All these values are going to be the same, and that is the succeeding term minus the previous term. Remember, you don't have to do A1 minus A2. The order does matter. So these values found like this. And the last term of an AP or arithmetic progression is denoted by AN. Now again, when here there are dots, that means this sequence continues, this progression continues. And when there is no last term given in an arithmetic progression, it is called an infinite progression. An infinite progression. But suppose here there it is given 31 and dot 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 and 31. That means this is the last term. After that there are no dots. So such a arithmetic progression which has a last term is called a finite AP or a finite arithmetic progression. So we know what are the things we have learnt. A, that is the first term. D, that is the common difference, which is always A2 minus A1, A3 minus A2 and so on. And AN, which is the last term in case of a finite progression. Now let us try to find how we can find out the nth term of any given sequence. Now when you know that A is 5, let us take an example. Suppose A is 5 and then A is given to you. Then what will be A2? The second term. It will be A, that is the first term, plus the common difference, right? Then what will be A3? That will be A2 plus the common difference. But what is A2? A2 is A plus D. So we write A plus D, which is A2, plus D. And that actually gives you A plus 2D. Again, what will be A4? A4 will be A3 plus D. But what is A3? A plus 2D. So you write A plus 2D plus D, which actually gives you A plus 3D. So just note this order. A is A itself, the first term. A2 is A plus D. A3 is A plus 2D. A4 is A plus 3D. So whichever number of term it is, one less value is over here. So if we want to find what will be the nth term of a sequence, then we can write it as A plus, in place of 4 here it was 3. So in place of n, here it will be n minus 1 into D. So this is a formula using which you can find nth term of any sequence, provided you know the first term, you know which term we need to find out, and you know the common difference. Actually in this you can see that there are 4 variables, an, a, n and d. So this is an equation in which you can find any one value when the other 3 are given. Now let us take an example. The question says, how many multiples of 4 lie between 10 and 250? So you have to find the number of multiples. That means you have to find the value of n. But before that, between 10 and 250, and 10 and 250 both are not the multiples of 4. So first you will write after 10, which is the multiple of just after 10, it is 12. So 12 is a multiple of 4, followed by 16, then followed by 20, and the last term should be just before 250, what is the multiple? And you know the divisibility rule for 4 is last 2 digits should be divisible by 4, and that is 48. So it will be 248. So this is our sequence, which is finite, where A, that is the first term, is 12. Because they are multiples of 4, means every time 4 is added. So D is 4 and AN is 248. So you have got these 3 terms and you have to find how many multiples. That means you have to find the value of N. So we know the formula for AN is equal to A plus N minus 1 into D. So we know all the 3 values, AN, A and D. Let's put the values. So AN 248 is equal to 12 plus N minus 1 into D, which is 4. Solving the equation, we get 248 minus 12 equal to 4N minus 4. We multiply. This gives you a 236. This comes here, plus 4 equal to 4N. That gives you 240. 240 is equal to 4N, and that gives you N is equal to 240 upon 4. 240 upon 4, which gives you 60. So, what do we understand from this? That between 10 and 250, there are 60 multiples of 4. We'll see one more example. So, here is our question. Ram started work in 1990 at an annual income of Rs 5,000 and received an increment of Rs 200 each year. In which year his income reached 7,000? So first you will have to find out that how many years it took him to reach from 5,000 to 7,000. Now how many years means N, right? And he started at 5,000. That means in this part we have A, that is the first term, as 5,000. Definitely every year there is an increase of 200. That means it is an arithmetic progression, right? So D, with the common difference D, is rupees 200. And he has to reach 7,000. That means AN, that is the last term, is 7,000. And you need to find that in how many years he reached from 5,000 to 7,000. That means N's value. Remember again, N is not going to be your answer. That number of years you will have to see. 1990. They have asked which year, not how many years. So your N should be added to this to get the final answer. So let us use the formula. So AN equal to A plus N minus 1 into D. So 7,000 is equal to 5,000 plus N minus 1 into 200. This you bring here, subtracts, and you are left with 2,000. 7,000 minus 5,000 gives you 2,000 is equal to 200N minus 200. Bring 200 here. So it gets added. So you get 2200 is equal to 200N. That gives you 2200 upon 200 is equal to N, and that gives you N is equal to 11. So after 11 years, that means 1990 plus 11. So how much will you get? Which year will you get? Plus 10 will become 2000, and this will become 2001. So in the year 2001, Ram's salary became rupees 7,000. Thank you. Hope you understood.